Okay, today we're going to be solving linear systems algebraically, and we're going to look at this example one. We're going to try to solve this linear system by graphing to show why we need multiple methods for solving systems. So the first thing we would need to do when we're solving graphically is get the equations into slope-intercept form. So I'm going to start with the top one. 4y is equal to 8 minus 3x. All I need to do here is just divide by 4, and I'm left with y is equal to 2 minus 3/4 x. If you don't like the look of this, you can just go ahead and switch the order, negative 3/4 x plus 2. And let's go ahead and plot this line out. Let's start at positive 2, the y-intercept, and then our slope is negative 3/4. So I'm going to go down 3 over 4, and I'm going to go ahead and put the second line in slope-intercept form. All I need to do for this one is add an x on both sides, and I'm left with y is equal to x plus 1. So my slope here, my slope and my y-intercept is 1, right? My slope is the value in front of x, which is 1. We just don't write it there. So I'm going to start with the y-intercept of 1, and my slope is also 1. So I'm going to be going up 1 over 1, up 1 over 1, or of course I can go down 1, back 1. So I'm going to go ahead and graph out these lines. Okay, there we go. And you can see we run into a bit of a problem here. We know that the solution to this system is the intersection of these two lines. Okay, so this right here is the solution. However, it's really hard to eyeball exactly where this point is at. I see that it's over about a half-ish. It looks a little bit more, and it's up about a half, a little bit more in that direction too. So I don't know the exact location here. So if we solve this algebraically, we can get a more exact answer. And we have two different methods to solve algebraically. We can solve by substitution, which is where we isolate one variable and we substitute it out into the other equation. And then we use elimination when we line up the variables, and we basically add them together where one variable will cancel out, okay? And basically, you're just going to choose the method based on whichever one's going to be easier to use, okay? So we're going to start with substitution here. I've got some steps for solving substitution here. We want to solve one of the equations for its variable. So when possible, solve the variable that has a coefficient of 1, okay? So I notice in the second equation here, I've got 1y is equal to negative x plus 1. So this one is a very easy equation to isolate for y. All I need to do is add an x, and I'm left with y is equal to x plus 1. Okay, now what we're going to be doing is taking this value. If y is equal to x plus 1, we're going to go ahead and substitute it out into this equation for this y, because y is equal to x plus 1. And the reason why we do that is now we're only dealing with one variable, so we can isolate it and solve. Okay, so now I'm just going to go ahead and distribute this 4, so I'm left with 4x plus 4. Let's kind of update this problem. All right, now I want to get the variables on one side and the constants on the other. So I'm going to go ahead and add 3 x's on the right, also on the left. It's going to cancel out over here. I'm left with 7x plus 4 is equal to 8. And now I just need to subtract 4, and divide by 7. And I'm left with x is equal to 4/7. Okay? And again, we're looking for an ordered pair. That's what the solution is. So I also need to find my y value. So at this point, what I can do, if I know what the x is equal to, I can plug it in for this x or for this x. We know that with a linear system, the x and y values are the same for both. So it doesn't matter which one we pick. I would just go ahead and pick the easier, which for this example looks like it's going to be this one. So I'm going to do y minus x, which we now know is 4/7, is equal to 1. And if I want to solve for y, all I need to do is add 4/7 on both sides. And I'm left with y is equal to 1 4/7, or I could call that 11/7 as an improper fraction. Either one is fine. So we have an x and y value. We should write this as a coordinate point or as an ordered pair. So this is going to be 4/7 x and 11/7 y. All right, let's look at a couple more examples here. First one looks pretty easy because I've already got step 1 solved for, right? I've got a y variable already solved for. Y is equal to 2x minus 9. So all I need to do is pick up this part of the equation and plug it in. Oops, not there. Plug it in for this y, because then I'm only dealing with x's and I can isolate and solve. So let's do that. We've got negative 3x is equal to negative 15 minus y, which is 2x minus 9. And I just solved this. Now, you can think about this as a negative 1, so we can distribute this and it will just change the signs. So I'm left with negative 2x plus 9. Let's go ahead and update this problem here. First thing we're going to want to do is combine like terms. We've got negative 15 and 9. So I'm left with negative 3x is equal to negative 2x minus 6. And I'm going to get my variables on one side, so I'm going to go ahead and add 2x's on both sides. And I'm left with negative x is equal to negative 6. And this you can think about as a negative 1x. So you can divide by negative 1, divide by negative 1, and I'm left with a positive 1x is equal to 6. All right, and don't forget we need an ordered pair, so I have 6 as my x value. Now to figure out my y value, I just need to plug in my x into either one of these two original equations. So I think for this one, it would definitely be easier to pick the top equation. So y is equal to 2 times x, which we now know is 6, minus 9, and solve. 2 times 6 is 12. 12 minus 9 is 3. So y is equal to 3. So let's write this as an ordered pair, 6 comma 3, and we're done. All right, last example of this. Number 3, doesn't matter which equation we choose to solve for. I notice that I've got a negative 1y and a positive 1x here. So we can easily solve either one of these, but I think it's going to be easier to solve for this bottom equation because it's a positive x. So I'm going to subtract out 8y's on both sides, and I'm left with x is equal to negative 8y plus 10. And now I'm going to take this expression here, which is equal to x, and I'm going to plug it in to the top equation. So I'm left with negative 3 times negative 8y plus 10 minus y is equal to negative 30. Give me some more room here. Okay, there we go. Distribute out this negative 3. Negative 3 times negative 8y is positive 24y. Negative 3 times positive 10 is negative 30. Drop down this negative y equals negative 30. And I just need to solve here. So let's combine like terms. We've got 24y and negative 1y, so that's going to be 23y minus 30 is equal to negative 30. And I want to isolate the 23y, so I'm going to get rid of this positive 30. I'm left with 23y is equal to 0. So what number times 23 equals 0? It's going to be 0. If you're not sure, you can just go ahead and solve this out as normal. Y is equal to 0. So again, we have part of our ordered pair. We know that my y value is 0. And now all we need to do is plug this back into one of the original equations. I think it's going to be easiest. Could you plug it into both equations to check? Yes, you could, but you're going to make it easier on yourself if you pick the better equation. So I'm going to pick the bottom one because it looks like it's going to be easier. X plus 8 times y, which we now know is 0, is equal to 10. And yeah, this is going to be really easy. 8 times 0 is 0, so I'm left with x is equal to 10. And look at that, it's already solved. So there is my coordinate point, 10, 0. So that is substitution.